Algoasaurus. Say it out loud. Algoa Bay reptile. Pretty evocative name, isn't it?
It really is, and it immediately tells you where we are, South Africa, near Dispatch.
And went way back in the early Cretaceous. But the fascinating thing about Algoasaurus is how little we actually have. It's a real scientific puzzle built from just scraps.
Exactly. And that's what we're going to dive into today, the story of this particular sauropod. We'll look at the science, what it tells us about the animal itself.
Right, and how that understanding has actually changed over more than a century.
And why even these few fragments are, well, pretty important for understanding that lost world.
Okay, so our mission today,
Mm.
unpack the science. We're looking at the original papers, Broom stuff from 1904.
And the more recent analyses that have tried to make sense of it all.
All right, let's get started right at the beginning. How did we even find out about Algoasaurus?
Well, the discovery of the holotype, that's the key specimen used to describe the species, it happened back in 1903, and it was pretty much accidental.
Accidental. How
Yeah.
so?
Quarry workers near Dispatch, they were digging rock out of what we now call the Upper Kirkwood Formation, and, well, they hit bones.
Okay, so far so good.
But here's the part that makes you wince. A lot of those bones, maybe even most of a skeleton, were apparently broken up and used to make bricks.
No, used for bricks. You can't be serious.
I am, unfortunately. It's a documented part of the story.
So you're telling me that somewhere, possibly still standing today in the Nelson Mandela Bay area, there could be buildings with bits of the first Algoasaurus baked into the walls.
It's entirely possible. A really bizarre thought, isn't it?
It absolutely is. And it just highlights how much history can just vanish, without anyone realizing.
It really does. Especially back then, the significance wasn't always recognized immediately. Luckily, Robert Broom heard about it.
The paleontologist.
Yes. He managed to salvage some pieces after the fact. In his 1904 paper, he mentions getting hold of a few fragments of vertebrae and ribs. Not much, but something.
And it was Broom then, in 1904, who formally named it Algoasaurus baueri. Algoasaurus for Algoa Bay. That makes sense. Who was Barr?
G.T. Bauer, another paleontologist. It's a common practice, honoring colleagues or influential figures in the field.
Right, right. So Broom names it. Did he have any idea what kind of dinosaur it was, based on those fragments?
He did make some initial comparisons. In that first paper, he likened it to sauropods that were relatively well known at the time, like Brontosaurus and Diplodocus.
Okay, so that immediately gives people a mental picture. Big, long neck, plant eater.
Yeah.
Even if those comparisons might be refined later.
Exactly. It's at a starting point. A large herbivore.
Now, those few fragments Broom rescued, they didn't all stay in South Africa, did they? I read something about a piece ending up in the U.S.
That's correct. In 1913, Broom donated a significant part of his fossil collection to the American Museum of Natural History in New York.
The AMNH.
Yep. And included in that donation was an ungual phalanx from the Algoasaurus holotype.
An ungual phalanx. That's a toe bone, right? The one with the claw.
That's the one, the very last bone in the toe. It's cataloged there now as AMNH FR5631. So yes, a little piece of this South African dinosaur lives in New York.
Amazing.
Yeah.
A single toe bone travels across the world and across millions of years.
Mm-hmm.
Okay, let's try to picture Algoasaurus. We know the material's limited, tragically so, but what can we actually say about its size?
That's the million-dollar question, isn't it? With such an incomplete holotype, size estimates are tricky. Very tricky.
But there must be some basis.
There is. We have a piece of a femur, the thigh bone. Based on that fragment, paleontologists have estimated the full femur might have been around 50 centimeters long. Maybe 20 inches.
Okay, 50 centimeters for a thigh bone. What does that translate to in terms of total length? Roughly.
Well, extrapolating from that and comparing it to other sauropods, some researchers have suggested a total body length of maybe 9 meters.
9 meters, about 30 feet.
Around that, yeah. But you have to take that with a big grain of salt. It's an educated guess based on very incomplete data. It gives us a ballpark figure, nothing more definite than that.
So maybe comparable to some of the smaller titanosaurs or diplodocids. Gives you a sense of scale anyway. Now, let's get into the classification.
Mm-hmm.
Where does Algoasaurus fit on the dinosaur family tree? That hasn't been straightforward either, has it?
Not at all. It's been a bit of a journey. Broom initially placed it broadly within Sauropoda,
Yes.
basically the big group containing most of the classic long-necked sauropods, the more advanced ones. For a while, some suggested it might be a titanosaur.
Titanosauridae, like Argentinosaurus in that crowd.
Sort of, yeah. That was proposed, but the evidence to really support putting it firmly in Titanosauridae just wasn't there. Most scientists now think that's pretty unlikely based on the known bones.
Okay, so it was in this big Sauropod bucket, maybe a titanosaur, maybe not, kind of floating.
Pretty much. It was considered Sauropoda incertae saties for a long time, meaning its precise placement was uncertain. Then things got interesting in the early 2000s.
How so?
A different idea emerged. Researchers, people like Canuto and Salgado and later Ibiracu and colleagues, looked closely at one of the neck vertebrae Broom had collected, specifically the shape of the neural arch.
The bony arch over the spinal cord.
Exactly. They noted that its shape shared some features with a group called Rabbitosauridae.
Rebisaurids, okay, I've heard of them. Like Rebicosaurus itself, Nigersaurus. What would being a Rebecasaurid imply for Algoasaurus?
Well, Rebeccasaurids were an interesting bunch, often a bit smaller, maybe more lightly built than titanosaurs or diplodocids. Some had really weird features like those tall neural spines forming sails or humps. Finding Algoasaurus was one of them would have been quite significant, especially in South Africa from that time period.
So the neck bone pointed towards Rebicosauridae. Was that case closed?
Not quite. Science is rarely that simple, is it? The plot thickened again more recently.
Okay, what happened?
In 2016, McPhee and his team re-examined all the known Algoasaurus material. They looked at that cervical vertebra, sure, and acknowledged the similarities noted before. But they also looked closely at the scapula, the shoulder blade fragment, and they found its shape didn't really match up well with typical Rebectosaurid scapulae.
Huh. So conflicting signals. One bone suggests Rebecasaurid, another suggests maybe not.
Precisely. Because of that conflicting evidence, they concluded that we couldn't confidently place Algoasaurus within Rebeccasauridae based on the fossils we currently have.
So where does that leave it now? Back in the uncertain bucket?
Pretty much. The current consensus, following McPhee et al., is to classify it as an indeterminate eusauropod. We know it's in that big group of advanced sauropods, but we just can't reliably pin it down to a specific family like Titanosauridae or Rebeccasauridae yet.
Indeterminate eusauropod. It really shows how just one or two more bones could completely change the picture, doesn't it?
Absolutely. And speaking of more bones, that 2016 paper did mention something else, potentially quite exciting.
Oh, what's that?
There's a specimen in the Iziko Museum in Cape Town, catalog number SAM-PK K1500. It's thought to be a caudal vertebra, a tailbone.
And it might belong to Algoasaurus, maybe even the original holotype individual.
That's the tantalizing possibility. It might be part of the holotype or maybe another Algosaurus individual found later. The problem is...
Let me guess. It hasn't been fully studied or published on yet.
You got it. It remains undescribed in the scientific literature. So until someone does a detailed analysis and publishes the findings, we just don't know for sure if it belongs to Algosaurus or what clues it might hold. It's a loose end.
Wow. A potential key piece, just waiting for its moment. Okay, so the classification story is a great example of science in action, proposing, testing, revising, based on evidence. Let's shift focus now to its world. What was early Cretaceous South Africa like?
Well, the fossils come from the Upper Kirkwood Formation. Geologically, that dates to the Berriasian and early Valanginian ages.
So right at the beginning of the Cretaceous period, we're talking, what, roughly 145 to 139 million years ago?
Somewhere in that range, yes. A very long time ago.
And the rocks tell us about the climate back then.
Yes. The sedimentology, the study of the rock layers themselves, suggests something interesting. It looks like the environment during the time Algoasaurus lived might have been transitioning towards drier conditions.
A drying climate. That would definitely affect the plants available for a big herbivore.
It certainly would have shaped the ecosystem.
And Algoasaurus wasn't alone there, was it? It shared this environment with other dinosaurs.
Definitely not alone. The Kirkwood Formation has given us fossils of quite a few other dinosaurs, painting a picture of a pretty diverse fauna.
Like who?
Well, there's Iuku, an iguanodontian, one of those thumb-spiked herbivores. There's also Peranthodon, which was a stegosaur.
A stegosaur, so plates on its back.
Yep. And then there's Enwiposaurus, a small, quite primitive ornithomimosaur, a bird mimic dinosaur.
Wow, so you've got big sauropods, iguanodontians, stegosaurs, small ostrich-like dinosaurs.
Exactly, plus other bits and pieces of dinosaurs that haven't even been formally named yet. So Algosaurus was living in a pretty dynamic and populated environment.
It really helps to visualize it, knowing its neighbors. It wasn't just wandering a barren landscape.
Not at all. And every fossil, even the frustratingly incomplete ones like Algoasaurus, adds a vital pixel to that bigger picture of life in the early Cretaceous in southern Africa.
Okay, so let's try and wrap this up. If we boil it down, What are the main things to remember about Algosaurus?
I'd say it's an early Cretaceous sauropod from South Africa, known from very, very incomplete remains found over a century ago.
And that incompleteness means its exact spot on the family tree is still debated, right? Currently pegged as an indeterminate eusauropod.
That's the key classification point for now, and the story of its discovery. Well, it's memorable.
Memorable and a bit tragic, with the bones ending up in bricks. A real cautionary tale about preserving fossils.
Definitely. It highlights the fragility of the record. And the scientific journey itself is fascinating, from early comparisons to Brontosaurus to the Rebacosauridae hypothesis based on the neck bone.
And then, the conflicting evidence from the shoulder blade leading back to uncertainty. It really shows science as a process, not just a set of facts. Hypotheses get tested, refined, sometimes discarded.
Exactly. It's about constantly reassessing based on the available data, even data that's been sitting in museum drawers for decades.
It really makes you think, doesn't it? How much of what we know about the ancient past relies on these tiny fragmented windows? A toe bone here, a bit of vertebra there.
And how new ways of looking at old evidence, or maybe even a lucky new find, could still change our understanding of animals like Algoasaurus, known for so long yet still holding secrets.
Which leads to a final thought, maybe, for you listening. Considering Algoasaurus and those lost bones potentially hidden in plain sight within old buildings.
What other fragments of Earth's deep history might still be out there, unrecognized or unexamined? What other stories are waiting to be pieced together from the clues we already have, or those yet to be found?